$350 billion. One Dutch company, that's what ASML is worth. And almost all of it rests on one thing: the assumption that no other country can build what they build. Picture the one machine that every advanced chip on Earth depends on. The machine that makes the transistors inside your phone, your laptop, every NVIDIA GPU, in every AI data center. One company builds it. One country houses that company. And for 30 years, the rest of the world has accepted that this will never change. The export ban the US placed on ASML was supposed to guarantee that assumption forever. China would never get access to EUV. The gap would only grow. The monopoly would only strengthen. Instead, it gave China the most powerful motivation it's ever had to build something nobody believed it could. And right now, inside facilities that weren't supposed to exist, it's building it. By the end of this video, I'll show you the one number that tells you how close China actually is. Not the optimistic number China claims. Not the pessimistic number ASML's CEO said in 2024. The verified number that changes how seriously you should take this. That number is the only honest answer to the question everyone is asking. Subscribe now before we get to it. Here is what China has confirmed, and what it reveals about how fast the gap is actually closing. Before we get to EUV, which is the headline, the DUV progress matters more for the immediate term. DUV is the technology one step below EUV. TSMC still uses DUV machines for a significant portion of its production. And China has now confirmed domestic DUV manufacturing at the KRF level, machines that ASML also produces and that were restricted in October 2023. That $8.5 billion projection isn't hope. It's procurement planning by Chinese chip fabs that have already committed to buying domestic equipment as Western alternatives become unavailable. Now, EUV, what China has and what it doesn't yet. Reports from multiple industry sources describe an EUV prototype undergoing testing, reportedly at a Huawei facility in Dongguan. The light source uses a laser-induced discharge plasma approach, different from ASML's tin droplet method. The lead researcher is Lin Nan, who spent years at ASML specifically working on light source technology before returning to China. Picture someone who helped build the most complex machine on Earth, working inside the company that built it, then choosing to go home and build a competing version using a different technical approach. That's not industrial espionage. That's knowledge transfer through voluntary human movement. And it's the one vector that export controls were never designed to block. But here's what makes this different from every previous Chinese chip announcement. This time, the machines they're building aren't just for China's own fabs. They're targeting export markets that ASML can no longer serve. ASML lost access to the Chinese market for its most advanced machines in October 2023. That's roughly $2 billion in annual revenue from China, gone. But the bigger threat isn't what ASML is losing. It's what's happening to the markets ASML still serves. As Chinese domestic lithography improves, other countries, particularly those in the global south building semiconductor ambitions, will have a second option. And that second option won't come with US export restrictions attached. The number that quantifies how fast this is moving, the one honest answer to how close is China really, right after this. Picture a race where the leader controls all the good roads. The challenger starts building its own road. At first, the road is rough and slow, then it gets better. Then other racers start using it, not because it's as good as the original, but because the original road has a gate on it that requires permission to use. That's the ASML situation in 2026. And the number that tells you where China actually is on that road is not what ASML says. It's not what China says. It's what the machines themselves are producing. Let's be precise about the gap and why the standard framing is misleading in both directions. ASML's CEO Peter Wennink said in 2024 that China is 10 to 15 years behind on lithography. That number gets repeated constantly, and it's misleading for a specific reason. That estimate was based on where China was in 2024 and projecting forward at the pace China had been moving. It didn't account for what happened when the export ban removed all remaining incentive to buy Western equipment and redirected the entire Chinese semiconductor equipment budget toward domestic development. You think 10 to 15 years means China isn't a threat until 2034 at the earliest. That estimate assumed China would keep trying to access Western technology and only build domestic alternatives as a fallback. After October 2023, domestic alternatives stopped being a fallback. They became the only option. That changes the investment pace, the talent allocation, and the urgency completely. Here's what's confirmed versus what's reported, so you can calibrate your own assessment. Confirmed SMEE, shipping domestic KrF DUV machines. Confirmed China's domestic lithography market growing at a pace that implies committed procurement decisions. Confirmed Lin-Nan ex-ASML Light Source Division, leading China's EUV program at the Shanghai Institute of Optics and Fine Mechanics. Reported but not independently confirmed EUV prototype testing at Huawei's Dongguan facility. Reported trial production targets for the second half of 2025. Reported mass production goals for 2026, which is now. The distinction between confirmed and reported matters. But here's the strategic reality. ASML is pricing in the threat regardless. The company's own investor guidance has acknowledged meaningful revenue exposure. Its stock has underperformed relative to the semiconductor equipment sector precisely because the market is already discounting the possibility that the Chinese market, and eventually adjacent markets, shifts. Think about what happens to ASML's $350 billion valuation if China achieves pre-commercial EUV by 2030. Not full parity, just pre-commercial. The Chinese domestic market is already lost. But more importantly, what happens to the pricing power ASML has with TSMC, Samsung, and Intel when a credible alternative exists, even at lower performance? Monopoly pricing requires an actual monopoly. There's a memory angle too that most coverage misses. CXMT, China's leading DRAM manufacturer, has been advancing rapidly using domestically produced equipment where possible. Its progress has been fast enough that US policymakers are now debating additional restrictions specifically on DRAM equipment exports. That debate is happening because the threat is real enough to require a policy response, not because it's theoretical. The ASML ban was imposed in October 2023. That's less than 3 years ago. The machines being described as prototypes today are the result of work that was already underway before the ban, and that accelerated dramatically after it. The next 3 years will show the output of the post-ban acceleration. That's the window everyone should be watching. Quick question, type 2030 if you think China achieves pre-commercial EUV capability by 2030 or 2035 if you think the gap is wider than current reports suggest. I read everyone, but the number I promised, the one honest answer to how close China actually is, we're finally there. The number is 2030. And here's why that's the honest answer. Semi-Analysis, the most credible independent semiconductor research firm tracking this, projected earlier this year that China reaches pre-commercial EUV tools around 2030. Not full parity with ASML's latest generation. Pre-commercial. Meaning machines that work, that can produce chips, that aren't yet at the yield and reliability needed for high-volume manufacturing. That's 4 years from now, not 10, not 15. 4. And pre-commercial in 2030 means commercial, at some performance level, somewhere between 2032 and 2035. Which means the window in which ASML's monopoly is structurally uncontested is shorter than almost any public estimate acknowledges. The caveats are real. Photoresist purity, precision metrology, manufacturing yield at scale. These are genuine remaining gaps, not minor details. A pre-commercial machine doesn't automatically become a commercial threat. but the direction of travel is confirmed. And confirmed direction at this pace is what changes investment thesis, policy calculation, and competitive strategy. What this means for you. 3 situations. If you follow semiconductor investment, the ASML thesis has always rested on an uncontested monopoly. A 2030 pre-commercial Chinese EUV capability doesn't end that thesis immediately, but it introduces a discount that isn't currently priced into most analyst models. The question to ask is not, will China match ASML? It's, when does a credible alternative exist for markets that aren't locked to Western supply chains? That's the inflection point. If you track semiconductor policy and export controls, the October 2023 full ban on ASML exports to China was supposed to freeze the gap permanently. The 2030 projection from Semi-Analysis suggests it bought roughly 6 years, not 15. That's still strategically meaningful, but it's a different calculation than policymakers were making when the ban was imposed. The next round of restrictions will need to account for what the first round didn't stop. If you follow the broader AI hardware race, the chips that run AI models are manufactured on machines that ASML produces. Any credible challenge to ASML's monopoly is simultaneously a challenge to the supply chain certainty that AI infrastructure depends on. The risk isn't that China's chips immediately outperform NVIDIA's. It's that the physical manufacturing layer underneath all of this becomes contested. And contested supply chains are more expensive, slower, and less reliable than monopoly supply chains. The people watching this video have been tracking a pattern across the last year of coverage on this channel. Every time America tried to stop China from accessing a technology, chips, rare earth magnets, EUV, antimony, China responded by building a domestic alternative that didn't need permission to exist. ASML's nightmare isn't that China built a perfect copy of their machine. It's that China is building something that doesn't need to be perfect to be useful, and doesn't need US approval to be sold. The export ban was supposed to be the wall. It became the mandate, and 2030 is when we find out how strong that mandate actually was. If this changed how you think about ASML, chips, and who controls the physical layer of AI, subscribe. The AI record tracks the infrastructure that determines who wins the next decade. Next, China also banned the export of antimony in 2024. 2 years later, Chinese researchers used that same metal to build a chip 100 million times faster on AI search tasks, using 10,000 times less energy. The material China restricted became the material China's breakthrough runs on. That story, coming next. $350 billion built on one assumption, that the machine could never be replicated. The export ban was supposed to guarantee that forever. Instead, it gave China a deadline. And 2030 is when we find out if the deadline was enough.